Hello everyone. In this video I'm going to do an example related to dot product and cross product. The question or the examples asks to find the volume of the parallelepiped determined by three given vectors in R3. So the first one is the vector U221, second one is a vector -4, 0, -2, and the third one is W 1, 0, -1. Okay, so let's see what does it mean questions like this. First, what is a parallelepiped? So if I have three vectors in R3, if they're good, meaning that they're not in a plane, then if this is U, this is V, I can generate a box which is of this form. The name of this solid object is called parallelepiped. Then the question is, what is the area, the volume inside this box? And we know that the volume of that parallelepiped is given by this formula. First, you cross product two of the vectors, U cross V, or V cross W, or U cross W. Pick two of them, cross them, then you get a vector. Then dot product that vector to the third vector. So I use two of the vectors here, then the third component, third vector I dotted to their cross product. Then I get a number. Here's a very important thing about this formula. The volume should be a positive number, but this guy sometimes is not positive. We have to change it to a positive number by taking its absolute value. Okay, so pick two of the vectors, cross them, then the result, you dot that cross product to the third vector. Then you got a number, but you have to make it positive. You have to make sure that it's a positive, so we find its absolute value. So let's do this thing for this specific example. So let me first find U cross V. How do we do U cross V? So these are two vectors, cover the first component, then put the remaining components of the first one in the first row and the remainings in the second row of a matrix, then find its determinant. For the second component, you cover the second components, the remainings you put in the first column, first row, and the remaining put in the second row of a matrix, find its determinant, then multiply by negative sign. This is very important. In the middle component, you have to multiply by negative. And for the third component, so you just cover the third component, put the remaining components of the first vector in the first row, the remaining components of the second vector in the second row of the matrix, and then find its determinant. What do we mean by determinant of 2 by 2 matrix? Let me write it here. Determinant of A, B, C, D is you multiply diagonal elements, A times D, subtract from that number the product of the off-diagonal terms. AD, diagonals, minus BC of diagonals. So then this means 2 times negative 2 minus 2 times negative 2 minus 0 times 1. I have a negative sign, so I put it outside bracket. 2 times negative 2 minus of diagonals are 1 and negative 4. So 1 times negative 4. I have to do that and then multiply by a negative sign. The third one is diagonals are 2 and 0. So 2 times 0 minus 2 of diagonals are 2 and negative 4. So 2 times negative 4. Yes. Then U cross V is this vector. 2 times negative 2 is negative 4 minus 0, so it is negative 4. 2 times negative 2 is negative 4 minus negative 4. So negative 4 plus 4, that's 0. Negative, you multiply by negative sign, is 0 again. And the third one is 2 times 0 minus, so this is 0, minus negative 8, which is 8. So far, I have found U cross V. Then the next step is find U cross V. It's a vector, it's actually here, dotted to the third vector. In this case, is this. Okay, let me write these things down. I know that the cross product is negative 4, 0, 8, dotted to 1, 0, negative 1. What is dot product? Dot product, you multiply corresponding components and add them. In this case, it means I multiply this to that, negative 4 to 1, add it, multiply second component 0 times 0, multiply third components, and add them. Here I have negative 4 plus 0, negative 8. I get negative 12. Well, the second step is done. I did this, I did that. Then I got a number. I have to find its absolute value, meaning that if it is negative number, drop the negative sign. If it is positive number, leave it alone. So then we know that now volume of that parallelepiped is absolute value of U cross V dot W. And we know that that number is negative 12. Absolute value of negative 12, drop the negative sign. So that's the volume of the parallelepiped determined by these 3 given vectors. Again, be careful about each part of this thing. Cross product of 2 of the vectors, the results another vector. You dot product to the third vector. You get a number. That number is not volume. You have to find its absolute value, meaning that if it is negative number, you have to drop the negative sign, and if it is positive number, just leave it alone. That gives you the volume, and we did do this example, and the volume of this example, volume of parallelepiped in this example was 12.